This is part 7 of the series, The Basics of Geometry, and we're going to start this part off with the concepts of perimeter and area. Put simply, perimeter is the measure of the distance around a figure, and area is the measure of the amount of surface covered by a figure. So if we have some basic shape, let's just say that we have some quadrilateral. Perimeter is this linear distance all the way around, adding the lengths of all the sides. Area is the amount of space that's inside that. And we're going to start out by looking at perimeter and area of a few different types of simple polygons. So let's begin. The first polygon we're going to look at is a triangle. So we have triangle ABC. Now generally we name the sides of a polygon with the lowercase letter of the letter describing the angle. We haven't talked about these things, but you can kind of see that this B is opposite that B and this C is opposite that C. Perimeter of this triangle is going to be given by the length of this side, so side A, plus side B, plus side C. If this were drawn in a Cartesian plane or in the coordinate plane, then we would probably end up having to use distance formula to find these two lengths and the ruler formula to find this length, and then going ahead adding them up to find perimeter. Now later on, as we get into more advanced topics, you won't be given that much information, and you're going to have to be using a lot of different types of relationships to find the area of triangles and perimeter of triangles. But at this level, we're just interested in finding the length of each one of the sides and adding them up. The area of a triangle, hopefully you remember, is 1/2 base times height. Mathematically, this can be rewritten as base times height divided by 2. Sometimes this form will be much more convenient. Sometimes this form will be more convenient. It just depends on the algebra of the situation, which one you should write, but they both mean exactly the same thing mathematically. All right, let's look at another type of polygon. Here we first have a rectangle, and the perimeter of this is simply the length plus the width plus the length again plus the width again. So that means we have 2 widths and 2 lengths. So the perimeter is 2 times length plus 2 times width, or you can use the distributive property and pull out that 2, and it's 2 times length plus width. Either way, it works out. That's the distance around that rectangle. Area, on the other hand, is simply the length times W sides. Think of the area as accumulating lengths moving all the way up from the bottom to the top of this thing. So length times width is the area. Now you can use the exact same formula for squares. This is a square because you can see that all 4 of these sides are equal. You can't see these, but these angles have a special relationship as well. But let's just assume that that's a square. In this case, perimeter is going to be the length of this side times 4, because there's 4 of them. You could do this formula as well, but there'd be a lot of redundancy because the numbers for L and W would be the same. So 4 times the side length is perimeter, and area is simply this side times this side, which is the side length squared. You could still do length times width. Now characteristically, it's more convention than anything else. Usually in a 2-dimensional figure, length is left to right, width is top to bottom. But that could change depending on your drawing, but that's just a general convention. All right, so let's move on and look at an example and see if we can't calculate that out. In this figure, we're looking for the perimeter of this triangle and the area of that same triangle. Now we have the coordinates for points A, B, and C, so we should have all the information we need. Now for finding perimeter, we're going to have to find the length of AB, the length of BC, and then the length of AC. Now, just as a general plan here, I'm going to use distance formula for AB and BC, but for AC, I'm not going to need to do that. So all I need to do is use the ruler postulate, which is a lot simpler than distance formula. It takes a lot less time. So let's go ahead and we'll start it over here. AB, distance formula. Take our points and stack them. So this is AB, 7, 11, and 3, 2. 7 minus 3 is 4. 11 minus 2 is 9. So that's difference of the x's, square, add square root. Difference of the y's is 9. So that gives us the square root of 16 plus 81. So that's the square root of 97. Now, let's do BC. So we'll do BC over here. And that's going to be 7, 11, 14, and 2. So 7 minus 14, negative 7. 11 minus 2, 9. SAS, square, add square root. That's 49 plus 81 square root. That's the square root of 130. And now for AC, that's all we have to do is use the ruler postulate, and we're going to use the x coordinates because we're going horizontally. So AC equals the absolute value of 3 minus 14, which is the absolute value of negative 11, which is 11. Now to find the perimeter, that's going to be the square root of 97 plus the square root of 130 plus 11. Now, these are irreducible radicands here, so the easiest way to do this is to put this in our calculator and get an approximation for the perimeter, which gives us 32.3. Now, I would not recommend that you put this in your calculator and simplify it around it, add this in your calculator around it, and add that to 11. Because if you make any rounding errors at all, that's going to compound an error and you won't get the exact same value. And you never can tell. You could be off by a couple of decimal points, and that could be just enough to get an answer wrong on a test or a quiz or something of that nature. Not to mention it's imprecise. So depending on the precision level required in the problem, this is the way you should do it. All right, let's look at area. Now the area is going to be 1/2 base times height. Well, we already know that the base is 11. So this is going to be 1/2 11 times height. Now to find the height, we're going to do another ruler postulate here. And the height of this triangle is going to be the distance from that point down to this segment, because this is a straight horizontal line or segment. So we're going to use the y coordinate 11. So 11 minus the y coordinate for this, which is 2. 11 minus 2 is the absolute value of 9, which is 9. So this is going to be 1/2 base of 11, height of 9. Let's make sure we put in our equals here. And that's approximately 49.5. Actually, it works out exactly to 49.5, but you get the idea. So our area is 49.5, and our perimeter, 32.3. All right, let's move on to the next topic. In this section, we're going to be talking about angles. Now, as you probably already noted, the list of defined terms that we're generating is increasing fairly rapidly. There's a great deal of vocabulary that's introduced in the introduction to geometry, and that's because we need a working vocabulary to be able to do any useful work. And so our next set of terms is going to start with angle. And an angle is simply a set of all points formed by two rays with a common endpoint called a vertex. So here the sides are called the rays, or the rays are called sides. The endpoint, the common endpoint of both of those rays, is the vertex of the angle. And all the stuff inside the angle is called the interior of the angle, and everything on the outside of the angle is called the exterior. If you're on the angle, it's neither inside or outside. So the sides are rays. The angle is made by the rays that come together. Now you can create an angle using lines, rays, segments, pretty much anything that joins at a common point. Those can represent an angle. Now, with this new term, it's important for us to be able to name angles when we see them in pictures. So that's going to be the next thing we're going to look at. In general, angles are named with 3 letters. The vertex must always be the second letter in the name. So you're going to have point, vertex, point. Point, vertex, point. This vertex must always be the second letter. It would be inappropriate to say angle BAC. That is not an appropriate angle. You could say angle CBA or angle ABC. And it's always preceded by this angle symbol here. Now, alternatively, there are times when you will have a number inside of the angle, in the interior of the angle, but there won't be a degree symbol with that number. That is not indicating a measure of an angle. That's indicating an auxiliary name for that angle. So in this case, we could say this is angle 1. Now, also alternatively, when you have a situation like this, where there's one set of rays coming together at one common vertex, this is called a non-ambiguous situation, and in that case, you can use the single letter for the vertex as the name of the angle. So this could also be angle B. Now contrast that with this picture. In this case, this vertex is the culmination of multiple angles. You have this angle, you have this angle, and this big angle, all joining with a common vertex of B. So it would be inappropriate to use angle B for anything in this picture, because angle B would be ambiguous. It would not be clear as to what you were dealing with in this case. So you could say angle ABC, angle CBA, CBD, DBC, ABD, or DBA. And again, angle B is not allowed in this situation because it's ambiguous. So that's a general way that we're going to be naming angles. And the next thing we're going to deal with is joining the naming of angles with the measurement of angles. But we're going to do that beginning in the next video. So I will talk to you in the next video.